Hi friends, Professor Flutterblaster here. We're going to have some fun with balloons, and the first thing I wanted to show you is what I call the balloon in the bottle. So all I've got is I've got a plastic bottle and I put a balloon on there. And if you give this to one of your friends and you say, I bet you can't blow this up, you can go ahead and try and blow as much air as you want to into the balloon, and nothing will happen. Why? Well, it's because the bottle is filled with air so that there's nowhere for that air to go. If we take a drill and drill a hole in our bottle, we've just created, there we go, we've just created a way for the air to get out of the bottle. Now if we try and blow our balloon up, and you can see that the air goes in the balloon because we're able to let the air out of the bottle. If I take my finger and put it over the hole, it'll hold the air in the balloon because now the air can't get back in. If I take my finger off, our balloon deflates again. Okay, now let's talk about tension in a balloon. I've got a balloon here. And if I blow it up, and I'm going to put my earphones on, if I take a single nail and put it on the balloon, it pops. Now, have you ever wondered how the magicians or the mystics from India lay on a bed of nails? If they laid on a single nail, it would poke into them. But if I blow up another balloon, and I have my bed of nails right here, you can see all the nails. If I take my balloon and put it on the bed of nails, I can push pretty hard and the balloon won't pop. Why? Because now the pressure that I'm exerting is spread over all the nails instead of just one nail. That's how the mystics lay on a bed of nails without getting hurt. One more thing that I wanted to show you. Here it is. I've got two balloons that are about the same size, and I've got a valve here. We're going to close the valve. There we go. Blow up one of the balloons. And put it on one side of our valve. There we go. Okay, we got it on our valve. Now I'm going to blow up the other balloon, a much smaller amount, and put it on the other side of the valve. And while I'm doing that, I want you guys to think about when I open the valve, what do you guys think is going to happen? So now we got our balloons. We got a bigger one and a smaller one. One of three things could happen. The air could stay the same. The air could flow from the big one to the small one, or the air could flow from the small one to the big one. Now, who thinks the air is going to stay the same? Who thinks the air is going to flow from the big one to the small one. Who thinks the air is going to flow from the small one to the big one? Well, let's see. I'm going to go ahead and turn the valve that'll then open it. As you saw, the air went from the small one to the big one. Why? Well, it's because of Laplace's equation. And Laplace's equation says that the pressure inside the balloon is inversely related to the radius. That is, the bigger the radius, the bigger it is across, the less pressure in the balloon. Since this was smaller, it had more pressure. This one's bigger, had less pressure. So, more pressure pushed the air from the smaller balloon to the bigger balloon. And that, friends, is fun with balloons.